Okay, so hello everyone. I'm Alina Papadopoulou from Innovact, and we are here today to present the XR5.0 webinar named XR and AI Enhanced Robotics Training. Today's session is part of the XR5.0 series webinar where its pilot showcases how XR and AI technologies are being applied in real industrial environments. So we can start with Georgios sharing his screen to see the agenda. Thank you. So let's underline a few quick notes on logistics on this webinar. At first, the webinar will last about 40 minutes. Feel free to use chat if you have any questions or you want to discuss anything. We will have a dedicated Q&A section and a live survey in the end. So we invite you to stay until the end. And now let's take a look to the agenda. First, we will start with troubleshooting and training use cases with Georgios Karantinakis. Then we will continue with Hololight Space and Haste for Robotics training from Hars Manosas from Holo. Then we will have Robert Feijer from Siemens, and he will present KUKA-Bot with RAG. And then we will have immersive training scenarios from Andrei Horlov from IML. And then we will have the live audience feedback, this survey. So I'm glad you are here, and Yorgos, the floor is yours. Thank you.
Okay, hello everyone. So my name is Yorgos Karantinakis, and I will be presenting on behalf of KUKA. So KUKA is essentially an automation powerhouse. We have 5 different business segments, systems, KUKA Robotics, which is probably the most and well-known one for the hardware, and software services, the digital part for digital solutions, such as digital twins, as in visual components, but also mosaics. Then we have the logistics parts from Swisslog and the medical part from Swisslog Healthcare. And we are from the systems part, so we produce smart and safe, efficient production solutions and offer them to various industries, general industries, but our main focus in the past was the automotive branch, and in future we will roll it out to more industries. In general, our business challenges are divided into 3 categories. So we have cost, innovation, and labor. So we need to reduce downtime, and we have a high pressure to cut costs and waste to be market competitive. Also on the innovation side, we need to see that we integrate advanced technologies into our existing systems, which is not that easy because they operate on different levels. And yeah, also on the training side, we have high complexity assembly lines, and thus the training needs to be more adaptable and have links to context-based solutions. So this is on the innovation side, and then on the labor side, we also have some challenges like shortage of skilled workers. And we would like to have a more human-centric approach and operations. And this is also to adapt to social changes in the labor market. So we have a new kind of workers that are more skilled with digital solutions. So our vision for this project, XR5.0, is that imagine that in a shop floor where extended reality could enhance with visible real-time machine data, overlaid onto the physical machine, guides the technician through immersive and interactive troubleshooting and training scenarios. And there's no more static data, and every data feed and instruction adapts dynamically to the user's context. And thus, troubleshooting becomes a collaborative experience. AI explains the results and shows them visually in the XR world, and yeah, enables the human to make better decisions, and the trainings becomes more easier and personalized through the AI part. Therefore, we have dedicated two different use cases. Use case one is personalized XR and assembly line production, which offers AR overlays and connects and retrieves data in real time from the machine, and thus also supports remote assistance by sharing this real-time data through the XR device. And through a personalized voice command XR interaction with speech to text and text to speech, we can have a better interaction with the XR device. The second use case is the virtual commissioning and Gen AI and robotics, where we use digital twins and we control them with process signals via OPC UA and have visualization of partly built machines. So very early on in the commissioning phase, we can already see what's going to be there in the future, and thus trainings, XR trainings, can be more personalized with step-by-step instructions. I want to show you a short overview about our pilot partners, which, we are the pilot owner. Then we have the pilot technical responsible, which is ATB, also from Bremen. We are both located in Germany, in the north of Germany, in Bremen. And then we have a variety of technical partners with different focuses that are spread all over Europe. And then I want to give the floor to Hololight for their application.
Yeah, thank you, Georgios. Hello, good afternoon, everyone. I'm Harsh from Hololight, and I'm a technical project manager within Hololight. And today I will present what we bring as an XR solution and how we use it in XR 5.0. So a bit on Hololight, we are a deep tech company focusing on foundational technologies for XR for more than 10 years now. And we develop XR software, XR streaming technology, and we have an XR ecosystem that we have developed in-house. And specifically within XR 5.0 and Pilot 1, we are using Hololight Space, which is our powerful XR software for design and engineering purposes that will help streamline engineering and product development processes. Next slide. So a couple of features that Hololight Space brings for engineering use cases is number one, our streaming technology. That is, you can bring in large 3D models directly into your XR headsets because all the rendering is happening on powerful servers, either on cloud or on prem. That would mean you can easily bring in large 3D complex models with high fidelity and a high number of polygons without any data preparation. And within this, you can interact with your 3D content. You have a range of manipulation tools that are provided within the application. We also have a space manager, which is essentially a way to manage the file hierarchy, understand what is the different components within your model and your 3D object. We also have a multi-user mode in which users essentially collaborate over a 3D object remotely, and we are able to do this between AR and VR experiences. We also have real-world referencing, let's say, features via object tracking, QR codes, and two-point alignment, allowing users to essentially overlay their 3D models over real-world environments. And lastly, we are a device agnostic solution. That is, we essentially cater to mainstream AR VR devices, right from Microsoft HoloLens to Apple Vision Pro, Magic Leap 2, Meta Quest series. We also have extensions to HTC Suite and also Lenovo. Next slide. With these features, you essentially have use cases in industries spanning from design review, factory planning, rapid prototyping. Then you can do risk assessment, quality assurance, plant design, and as well as product presentation. And here are some images on how we essentially bring the 3D models into lightweight devices, and we do not compromise on any quality of the 3D models. Next slide. So within Hololight Space, what we are doing is essentially we allow a 3D model import of a KUKA robot crawler. And in the first image on the left, you will see that users essentially get a view of a 3D model before they essentially load the model into the space around them. And this allows you to configure your 3D model as per in terms of scale or in terms of alignment methods. In this particular image, you can see a dotted line that goes to the ground because I've selected an option to align it to the ground, to my physical ground essentially. And once I apply it and load the 3D model, on my right, I essentially get a 3D visualization of the robot crawler, which is a 1:1 representation. That means it's true to scale. Can move to the next slide. And with this, what we also do, we have a digital twin essentially, wherein we have the sensor data, specifically the distance sensor, and we read this data directly from the machine and directly from the OPC UA server. And that's the image on the left, where there are 6 distance sensors, and in real time, we are able to see the distance values that are recorded in real time. And on the right, you see the explosion view. That is, you are able to explode the model in 3D to be able to see what's within the model as well, to give a perspective to the users and technicians who are using this application. Could move to the next slide. And a couple of integrations that we have is one, the XR training programs that will be further highlighted in the following session by Immersive Lives, wherein we are essentially bringing in training mechanisms for the technician to undergo, specifically on the robot crawler, and also specifically regarding robotics use cases. And in the second image on the right, we have the KUKA-Bot integration, in which we essentially have an AI assistant to which you can query specifically about KUKA's technical manuals, and you can, along with your 3D model, you can operate and query to the chatbot and understand and help yourself train on the shop floor in any scenario that is within the robotics environment. Next slide. This is a snapshot on how we are right now currently bringing in robot simulation data into our 3D application. And here you can just see a simple KUKA robot arm that is essentially going through a range of motion. And this information is being fed like from the machine. Right now, the data is simulated, but within this pilot and within the project, we will eventually have real-time control from a technician. That is, the technician will be able to control, remotely control the movements of a robot arm on the shop floor directly. Next slide. So, yeah, to conclude, what's next for us within the project and within this pilot is that we will have a native app assistant that will allow the technician to navigate all the 3D CAD features and functionalities so that it is easy and seamless for the user to use XR application. We will have a safety zone checker in which as the user proceeds, like let's say very close to the robot, there is an alarm within the headset which will ring and alert the user to not be too close to any robotic systems. We will have voice-driven user interfaces. That means the user can essentially control the entire user interface purely by voice. And as you saw, we are currently working on the robot simulation remote control. And lastly, we will, within project, also integrate with the XR5.0 training platform to achieve a cloud streaming solution. And to conclude with the benefits that we bring for XR5.0 and also for KUKA is that there is no model simplification required. Exactly how they prepare the model, we can directly use it within the XR application. We get high performance on lightweight devices via streaming the entire application, leading to high fidelity 3D visualization and also interaction, giving the users an improved spatial understanding. And we have from the beginning designed a secure and scalable solution so that so it brings the most, let's say, benefit to the end user. And we also have cross-team collaboration via multi-user mode, where you can bring in several technicians into the same XR session. And by this, we are essentially supporting a handful of real-world engineering use cases. With this, I conclude my presentation, and I hand over to Robert.
Thank you, Harsh. Hello, my name is Robert. I'm a data scientist at Zimos, and today I will present you the KUKA-Bot, the backend service that powers querying the datasheet documents for KUKA. So regarding our current reality, there are lots of manuals and technical documents. Engineers need to dig very deep in them to find the required information. And some of the information might span across multiple pages. Our solution can be summarized as AI voice assistants similar to ChatGPT, but with incentivize for the integration with XR environments, such as the one that was presented by Harsh previously. The service spans into two main processing workflows, one for processing documents and the other one represented by the assistant. It can encapsulate hundreds of technical manuals, and each of those manuals can be updated, removed, or added to the knowledge base. The main advantage is that you can ask question in a plain language, get on point answer with sources, so the engineer can verify by himself if he wants to get additional information from the documents. And also we support a multitude of responses via voice, text, or imagery. Next slide, please. Okay, so how this works. First, I want to explain the RAG, which is the retrieval augmented generation technique, which empowers the LLM. Because in traditional LLMs such as ChatGPT, we have a limited baseline of knowledge, which most of the time can be outdated. It can also hallucinate facts, and most of the time we can get a series of generic answers. What adds the RAG to the table? Let's say we select what documents we want to use for our knowledge base, so we can set them as context for our AI, and by doing this, we can generate more grounded and accurate answers. This diagram that you see on the right, it's a simple representation of workflow done by the RAG system. The steps are annotated on the reverse clockwise order. So the client asks questions. We do a semantic search on vector embeddings, which are represented by our knowledge base. The most relevant contexts get bring back to the system. And using them, we assemble a prompt for the large language model, from which we can extract and get a final answer, which is sent back to the user. Can we go to the next slide, please? Okay, so getting back, this is the high-level architecture for our KUKA-Bot implementation. As you see, this architecture seems pretty complex, but it resembles the two-step part, which is represented by the document processing and the RAG assistant. All the solution used for this implementation are open source, so they can be replicated on any machine. We use doclink to parse documents and extract extract the best contents, which are text contents, figures, tables, and other types. Afterwards, we have a pipeline for processing and filtering out the contents that we don't need. And in this process, we also use LLMs to enrich our contents for images. For instance, we need to have like explanations and to extract via OCR labels and other identification metrics that could be used when querying those types of contents. The RAG assistant part features a similar workflow on which we do a list of complex steps to identify the user intent, what knowledge base or what document is he referring to. And also we have a step to extract additional filters. Once the request identification is clear, we can get the answer and query the vector database and send a response back to the user. Next slide, please. As I said, our solution uses a stack of open source software. So we have a couple of advantages on doing this. So we can have on-premise deployment that ensures data sovereignty, compliance, and network isolation. KUKA also needs this solution for their privacy. Our responses allow for good XR integration, as I said previously, that we have a multitude of responses. We are using currently local storage, so S3 compatible buckets such as MinIO at a high throughput with the cost efficiency. We use the LLMs to enrich our resources, such as table, images, and text, as previously discussed. We detect the user intent, which would be to retrieve an image or to retrieve a list, to ask just a plain question or to get a summary. And we support on-fly indexing, which means that the user can add or the engineer can add documents to the knowledge base and delete them as the application is running. Some disadvantages for this approach include, of course, the infrastructure requirements, because you need the hardware resources, the maintenance overhead, and also you have the GPU dependency. The open source models also are limited, so you have smaller LLM models which are more prone to hallucination due to reduced context windows. And yeah, this also affects the accuracy of the responses. Okay, I think this is it from my side. Thank you very much for your attention, and I will give it to Jaime.
Hello, my name is Andrei, and I'm XR developer from the Immersive Labs. Today I will show you how our XR system is working, like together with our pilot partners. So you can see the scheme. It's very simple. So it's our solution is consists from the two tools: is training programs authoring tool and XR training plugins. And training programs authoring tool is a web-based authoring platform which is used by training manager. So they can convert all the data. So later on, it can be seen in the XR application by operators. So the screenshot below you can see. So on the left it's a web-based application, and on the right is XR training plugin. So our system can turn ordinary materials like PDFs or manuals into structured training content. With just one document, system can generate interactive checklist, extract text and images. It also allows you to upload images, videos, and 3D models in a regular way, and so on. So it's reduced the time needed to create XR training scenarios. And inside XR application, operator can interact with all training materials created by manager. At the moment, we support 3D Model Explorer, where operator can inspect machines and components in real scale. Interactive checklist, where operators step-by-step can do like all procedures step-by-step with confirmation and progress tracking. Also video playback, it's like where you can see the video and also use some annotations to see like all the details about it. It also includes AI assistant, so operators can ask questions about procedure or safety instructions. So we also our platform is compatible with OpenXR devices such as like Quest, Magic Leaps, and HoloLens. It's also supports cloud streaming and cloud repository. And like benefits which you can get is like unified process. So manager creates, the operator learns, and everything through like our system. And faster training material creation. So there are no developers needed to create XR training. And it's reduced human errors through checklist and structured steps. It's also very fast to update if some procedure is changed, and better retention through immersive spatial learning. And like our goal is to remove the technical barriers so manager can focus on procedure and system translate into immersive training. It was a bit short, but yeah, right now it's a demo.
The manager can create workflows to make it easier for the operator to navigate and use the content. They can also open a PDF file and extract a checklist in just a few clicks. Later, the same PDF can be used to extract an image. Additionally, another image can be uploaded directly through the Select Asset button. All the content, workflows, and resources are accessible in XR, providing a clear and interactive overview. This makes it easy to explore and manage everything in one place.
Yeah, that's it. Thank you for your attention.
The manager
Perfect. So thank you very much to all of our speakers for these great presentations that we had. Now we will move forward to the live survey. I will share my screen. Okay. Okay, I think that you can see my screen, right? So,
Yes. We can see it.
Yeah, thank you. So, to start the live survey, you should scan this QR code with your mobile device, or you can go to menti.com and use this code we can see here up on your screen. So I will wait a few seconds to all log in to this. I will do it also with my mobile. Perfect. So here, yeah, you can see the first question. It's, would you use XR environments in your daily work? So you can choose from all these answers. I will wait a little bit more. Okay. I think now I can move forward to next question. So, how often are you using AI in your daily work? Let's answer to this one. Let's wait a little bit more. Okay, so next one. Okay. Okay, just a moment, something went wrong here. Sorry about that. Just a moment, please. Okay, it works now. Perfect. Okay. So, which application did you find most relevant to your daily work? Okay, let's wait a little bit more. Perfect. Here you can write like one small line for the question, which step in the XR guided apps to do out to you?
By the way, just to say that we're going to share the results of the live survey with everybody registered in the webinar.
Perfect. so I can move forward. Okay. I will wait a little bit more. Okay. So, next question. How much would you be spending on XR hardware devices? Very nice. Would you like more information about RoboSpace, KUKA-Bot, training platforms, or you don't need more information at the moment? Perfect. Something went wrong here also, so just a moment, please. Okay. Sorry about that. Okay, so our last question. Do you have any feedback or comments? Of course, we will send you all the relevant link from presentation and the recording. Nice feedback about KUKA-Bot.
To respond to this question, currently it's not a commercial offering. It was developed for the pilot one use case. So currently we are more looking on the way of improving it and make it usable in a real environment. So before we are thinking about the money, we need to think about the research and how we need to invest to make a great product.
Thank you.
Elena, I think it's best in the page of the webinar to provide the recording, the presentations in PDF, and any other links we can share from the project. I don't know, from the project, deliverables, paper, anything related to this training. I mean, right? Not unrelated stuff.
Yeah, perfect. Yes, of course. Okay, so thank you for your feedback. Now I can stop sharing my screen and we can go to the Q&A section. So if you have any comments or anything that you want to discuss with us, please feel free.
it seems we have all answered all questions.
Yeah, or there are not bold people to ask questions, right? You know, remember most people are shy, right? They are afraid to answer and to ask and so on. So in this case, we can close the webinar. I think it's good to set up the page and also share with everybody registered, not just the people here, the outcomes of the survey and any relevant reading material on the same page.
Perfect. So we will come back to you with all the material. So thank you all for being here. It was
We can
very
also stop the
nice.
recording maybe. And
Yes.
yeah, thanks everybody, especially the presenters, right?